Hi everyone, welcome back. This is Polynomial Functions Unit Objective 2. So this is a lot of graphs and looking at a graph and breaking it down. So a lot of pictures. These are all polynomial graphs. That's why it's in the Polynomial Functions unit. So the first thing we're going to talk about are something called bounces. Bounces, which may be new, are how the graph turns. So some examples, here's some good pictures. It's how it curves up or it curves down. It curves down or it curves up. These are called bounces. And so if I'm asking you how many bounces does a graph have, you have to know how to find that. So in yellow, I'm telling you that you find the bounces by taking your degree and you subtract 1. This is always the equation for bounces, degree minus 1. So if I give you an equation that looks like this, and I'm saying, how many bounces would this graph have? The first thing you need to ask yourself is what is the degree? You need to know what the degree is. So degree, by definition, is the largest exponent. So when I look at this problem, what is the largest exponent that I see? It is 5. Okay, that is the largest exponent that I see. So if I want to find bounces, I take the degree, which is 5, I minus 1. My graph would have, if I graph this, it would have 4 bounces. It would have 4 turns, curves, whatever you want to say. Okay, next problem. Again, how many bounces? Find the degree. Your biggest exponent, 7. If you do 7 minus 1, 6. So this one turns a lot, right? 6 different times. So you will have a question like that. Find your largest exponent, minus 1. That's how many bounces that graph would have. Okay, another type of question you're going to see are something like this, where I give you a graph and it says, what are the x-intercepts? Hopefully this is really easy. It's just, where does this graph, where do these lines cross your x-axis? Remember, x-axis is the one that's going left to right. And then we just list it out. So I'm seeing it cross at -3, right? When I say cross, it goes right through -3. It's going through 2. And then lastly, it's going through 5. That should be an easy problem. You just list out what numbers it goes through. Okay, slide 2. A lot of these graphs are going to have what we call end behaviors, which is how it ends. How do your arrows end at the end of your graph? So we need to know, just like how many bounces it has, we need to know, how does it end? How do your arrows end? And there's a lot of different options. They could both be going up. They could be going opposite ways. They could be going opposite ways in different directions. So you have to know what your arrows are doing. And that's all based on either the degree or the leading coefficient. So remember, degree is your largest exponent. Well, that number could be either even or odd. So like back in our first slide, we had a degree of 5 and a degree of 7. Those are both odd, right? You could have a degree of 4 that is even. So your degree tells you something about your arrows. Also, what tells you something about your arrows is the leading coefficient. Leading coefficient is the number out front. So is that number out front negative or is that number out front positive? That also tells you something about how your graph ends. Okay, so what we're going to do is we're going to go over what these different things tell us, and we're going to drag these arrows into the correct boxes. Okay, so if your degree is even, what an even degree means is that your arrows will go in the same direction. Okay, that's what even means. They're going to be even on both sides, going the same direction. Something like this graph, where they're both going the same way. Not like this graph. This graph is going opposite ways. Okay, now if your leading coefficient is negative, that means that your graph will also be going down. So the same direction, but going down. What that looks like is this picture here. They're going the same way, but they're both going down. Okay? And maybe you can kind of guess, what if your degree is even, but the leading coefficient is positive? Positive means up, right? So if I look at these arrows, I'm looking for the same way, but up. So here is the picture that goes along with that. The same way, but they're both going up. Okay? Now, odd means that your graph is going to be going in the opposite direction So that's something like here, where it's going opposite. This last slide shows two different opposite directions, okay? But, and think about odd, opposite. But this is still the same. Negative still means down, and positive still means up. I'm gonna move this table up a little bit so I can see my options. Okay, so negative still means down, and then positive still means up. All right, so what does it look like to go in opposite ways but down? And what I want you to focus on is the last arrow going down. How does your graph end? It's going down. So out of these two options, they're both going opposite ways, but which one has the last arrow, that right arrow, ending down? That would be this one, because if you notice, that last arrow is going down. And then on the contrary, which our last one is going opposite ways, but that last arrow is ending up. So this would be the last one. Okay? So you fill out that table, and that's what those things mean. Now I'm going to test you on that. So when you look at this graph, let's break them down. Is the degree even or odd? So look at the sides of your graph, how your graph is ending. Is this graph both going the same direction, or is this graph going opposite directions? Well, I can see both of these lines are going the same way, right? So same means even. So I'm going to highlight even. And then now, yes, they're going the same way. They're going up or down. They're both going up, right? So I know that means positive. Okay. Now, this one is very different, right? I can tell right away these are going opposite directions. So I know opposite means odd. And then now I got to think about, is it positive or negative? Well, this last part of my graph on the right, is it ending up or down? It's ending up, right? It matches these arrows where the first one's down, the last one's up. So that means it's going to be positive. So really use this table to help you match up your arrows. All right, one last slide. So this slide is already giving you graphs, and it's saying which equation would produce the graphs. What I would think about with these is first where it crosses the x-axis. So yeah, where it crosses the x-axis, and then about your degree. So does the degree match how your graph is looking? And then do the numbers match? So first, this purple one, it crosses at -2 and -4, right? When you put this in an equation in parentheses, the signs have to change. So this -2 would become a +2. This -4 would become a +4. So actually, all these equations look right as far as the numbers in the parentheses, which is good. Now we have to think about, what should our degree be? What should our degree be? So this graph is definitely going opposite directions, right? So we know our degree should be odd. Odd means opposite. So which of these equations have an odd degree? Now, these are a little bit different than when I showed you degree before. So what you have to do now with these ones is you have to actually add up your exponents and see which one gives you an odd number. So for example, if I added up 2 plus 2, that would be 4, right? 4 is not an odd number. The second one, I don't see any exponents, but if you don't see a number, you can always assume that there is a 1. So if I would do 1 plus 1, that would be 2, right? That's an even number, so that's not odd. My last one would be 1 plus 2, that's 3. Here is my odd degree, so that would be my answer. And let's do it all over again. So I know there's no numbers here, but you can see that this graph crosses 1, 2, 3 times, and it's going to be 1 negative and 2 positives. So if you would flip those signs, right, the negative would become a positive. Well, actually, let's stop before that. It crosses 3 times, right? 1, 2, 3. So I know it's definitely not letter A because this has 4 different parentheses. So I know it's not A. So it's either B or C. So it crosses once on the negative side and twice on the positive side. And remember, we're going to flip those signs. So this negative should become a positive, And then my two positives should become negative. So if I look, well, this one has all negatives, right? Remember, at least one should be positive. So that is already showing me that it's this last one. Okay, so just be careful. These ones will be a little bit trickier, but just take your time, focus on where does it cross, how would it go in the parentheses, and then your degree. Okay, good luck on quiz number 2.